Hi, I'm Rhett Jesse, and today we're going to talk about the Metrix digital proximity system. Today's demonstration is going to show the interchangeability between metrics and a competitive system. We're going to first show the linearity of a metric system, and then the linearity of the competitive system. And then we're going to mix a probe and a cable with both the competitor system and our system and see that it's linear too. We're going to see the versatility of the Metrix MX2034 transmitter. Now, I'm going to be using the transmitter, but everything I do you could also do with the driver. So the driver is a 3-pin driver, and that would go to a monitoring system. And really anybody's monitoring system that can take 200 millivolts per mil or 100 millivolts per mil or 7.87 millivolts per micron, whatever that is. So the digital proximity system is very versatile. This is our driver. Now, I'm going to be using the transmitter. This particular transmitter has 4 pins. The first 2 pins are for loop power, and that would go to a control system. That provides the 4 to 20. That would go to your normal control system or to a PLC or a SCADA system. It would go to any one of those. And then we have another 2 pins that go directly to the signal in common pins of a monitoring system. So if you had, you wanted to see both the 4 to 20 to a control system or the signal going to a monitoring system at the same time, you could. And you can also still connect test equipment to the BNC without causing a problem with the 4 to 20. It makes our system pretty unique, and that's why I'm going to demonstrate it today. So let's go ahead and get started. Let's run a curve and let's see if how linear the Metrix system is. I have a 1 meter probe and a 4 meter cable for a 5 meter system, and that's going into this transmitter, the MX2034 4-pin transmitter. Now I have the bottom taken off. You can see normally we have a DIN rail mounting on it. I took off these 3 screws, and now that it gives us access to the USB that's underneath it. So I'm tapped into that USB right now, and I'm connected to my computer. What we're going to do is we're going to go ahead and take data. If I go to the home screen here, we'll start there. All right, so when I look at the Metrix digital proximity system software, we can see we have serial number 112205, and that's the same serial number that's here. All right, we also have a position 4-wire system, MX8030. It's 4140 steel, 8 millimeters, 5 meter system, and we're set for 10 to 90. So that's the setup, and we're going to go ahead and take data and check out linearity, and we'll do that quickly. We'll go ahead and gap it to 10 mils. All right, I've gapped the digital micrometer to 10 mils, and now I'll go to the verification tab, and we'll take our first data point. We'll take data every 10, 20, 30, and 40 mils all the way to 100, and then we'll look at both the linearity, incremental scale factor, as well as deviation from straight line. All right, then we'll take our last data point. When we take that, we'll see that it's very linear, and our incremental scale factor is between 190 and 210. Now it only had to do that between 10 and 90 mils, but we've got the full 80 mil API range within those limits, so that's very good. Let's take a look at deviation from straight line. That looks very good. It's between 1 and -1, and that's where we need it to be. So all the limits look good, and that's what we wanted. So now what we're going to do is we're going to change out the Metrix probing cable with the competitive probing cable, and we'll see how that works. And now we're going to do that without changing the configuration within the digital proximity system. All right, we've changed the setup, and now we have the Bentley 1 meter probe and 4 meter cable. So we have a full competitive 5 meter system. Now we're going to run a curve on it without changing the configuration inside the digital proximity system. All right, we've gapped the Bentley probe at 10 mils, and we'll take data every 10, 20, and 30 just like we did before, and we'll check the linearity of the system. All right, this is the last data point, and it's still within API, which is great. So the VN system, or the competitive system, worked very well as the metric system. Now let's take a look at deviation from straight line, and let's just see how we did. And I'm sure we'll find it's within limits. Yeah, very good. Well within the 1 to -1 values that we expect, and that's great results. So we had very good linearity. Deviation from straight line was in specification, and now we'll go ahead and try a mixed system. What we're going to do now is maintain the competitive probe and disconnect the extension cable and put in the Metrix extension cable. And that will show that it works with that mixed system. Now some people call that a Frankenstein system. You know, hey, it's mixed, it's unnatural. But when Mary Shelley wrote her book on Frankenstein, that was a long time ago, and things have changed drastically. Plus, Frankenstein's a myth. It's natural to be able to put probes and cables together and have them work in the modern 21st century. That's just the way it is, and I'm going to show you that. All right, so what we've done is we've changed out the extension cable and maintained the Bentley probe. Now what we're going to do is run this curve over again without changing anything inside the digital proximity system and show you that it works. That's what we call interchangeability. That's what we call the new normal. That's what the 21st century brings us, is digital configurability. It's different than the way it was in the past. Just to show you that we're still the way we were before, still the same configuration we started with, I'm going to go ahead and gap this to 10 mils. All right, we're gapped at 10 mils, so we'll take data every 10 mils, 10, 20, 30, 40, out to 100. We'll see how it looks, and we'll compare that to how we've done previously. We'll look at the incremental scale factor and the deviation from straight line, just to see if it's within specification. You know, you look at the data points, and you look at it and you go, well, that 188's out of spec, it's below 190. Well, that's interesting, isn't it? Well, the API says you need 80 mils of linear range. Now, I could easily correct this in our system. I can go do a tuning step and a custom calibration to get it perfect. But this is just, you know, something that out of the box, what it looks like. And then you look at it and you say, okay, that's out of spec, but no, it's actually in spec, because you can go 20 to 100 and still meet the specification. And in the sweet spot at 50, when you're gapped at 50, you know, you're right where you want to be. You're right in specification, so that's what's important. So in summary, we've been able to show you that the metric system is linear, the competitive system is linear, and a mixed system is linear. With the digital proximity system, you can actually have a competitive probe remain in the system and replace its extension cable and its driver or its transmitter with our system, and it will work. That saves you time, it saves you money, and it's really what we're trying to do for you. We're trying to make your life easier. Thank you very much.